The diagram shows a wedge, all of whose faces are smooth, resting on a horizontal table. The mass of the wedge is 3m. The faces of the wedge both make angles of 45 in here. Particles of mass 2m and m. 2m and m are placed on and released from rest. So A is the acceleration of the wedge. Okay, we'll call the acceleration of this one B. We will call the acceleration of this one C. So let's have a look at my forces. So we have 3mg, and I call my reaction here S. I've got my 2m over this side, so 2mg. I've got a reaction on both sides, so I'll call them R1 and R2. I've got my 45-degree angle on both sides. I have M on this side, so I have mg. I have R2 and R2. So if we take them on their own, let's start with the 2m over here. So I've got 2mg coming down, perpendicular to the plane. I have 2mg, and it's adjacent to 45, so cos 45, which is 1 over root 2, so it's just 2mg times 1 over root 2, which is 2mg over root 2. And similarly, we're going to have the same force coming down this way because of the 45-degree angle. We're going to have 2mg over the sine of 45, or times the sine of 45, which is times 1 over root 2. So 2mg over root 2. Now, the acceleration here, we have to resolve along this line. I have my acceleration of A in this direction. So that's the hypotenuse. So I need my right angle over here. So along this side, I have 45 here, corresponding to the 45 down here. So they're both going to be A over root 2 here because of the 45-degree angle. A over root 2. So my acceleration, if it's B down in this direction, is B minus A over root 2. And if we do our forces in this direction, we've got 2mg over root 2. This one here is equal to ma, 2m, times my acceleration, which is B minus A over root 2. So that's my first equation, perpendicular. Perpendicular, I've got down my R1 here. So perpendicular to the plane, well, it's going in this direction, so the force is downward, whereas on the opposing side over here, the force is pushing into the block, the force is upward. So we're going to start with this R2 when we do our equation, when in this case we're starting with the 2mg over root 2, this guy, 2mg over root 2 minus R1 is equal to m, which is 2m, times the accelerations were the same, weren't they? This is the one we're looking for, perpendicular, times A over root 2. So there's two equations for the first particle. So let's look at our other wedge, or other side of the wedge. Got my particle, m, isn't it? M on that side. We said the acceleration was going to be c. We've got an A as well. We have mg coming down, and we have a 45-degree angle. And we have our R2. So coming down in this direction, we're going to have, just going to color this angle in and go for, just write 45 here. We know that's 45. So again, because of the 45-degree angle, parallel to the plane and perpendicular to the plane are going to both give me the same mg by the cos of alpha and the sine of alpha, so just mg over root 2 in both directions. Mg over root 2. The acceleration is positive, so we're going to have an addition here. So let's have a look at our acceleration. So we've got a going in this direction, and we've c going in this direction. So we want to resolve what's going on. So if I take, sorry, a is going in that direction, a. So that my hypotenuse, my right angle, is over here. So because of the 45-degree angle, they're both going to be a over root 2, that side, and this side, a over root 2. So my acceleration down the plane is c, so here we're going to have c plus a over root 2 for my acceleration. So if I resolve the forces in that direction, I can say mg over root 2, this one here, is equal to m, which is just m, times a, which we've just gotten to be c, plus a over root 2. If we resolve perpendicular to the plane, we start with the R2 because it's pushing in, the wedge is pushing into the block, so we have R2 and we have mg over root 2. So R2 minus mg over root 2 is equal to m, and a in the perpendicular direction, it's going to be the same, but there it is there, a over root 2. And if we can sub R1 and R2 back in, I don't think we need the other two equations, but what do we look? We need the wedge, and we need to sub R1 and R2 into it. So let's get the equation for my wedge. So I've got my R's, I've got my R2 on this side, and I've got my R1 on this side. And with the 45-degree angles, we are going to be able to do this quite easy. So that's R1. So straight down is R1 sine 45, R1 over, sorry, cos 45 for that one, root 2. And in this direction, we also have R1 over root 2. If I just do the right hand side out again, R2. So R2. So again, coming straight down, adjacent to that 45 that's in there, we have R2 over sine over times 1 over root 2, R2 over root 2. And in this direction here, I also have R2 over root 2. So you can see they all work out the same here. So my equation, the block is going in this direction, or the wedge going in this direction, so that's R1 over root 2. Opposing it is R2 over root 2. This one here. That's equal to MA, which is 3M. Was it 3M? Was 3M times A. So we can solve now. We can find the acceleration by subbing in R1 and R2. But I'm going to multiply by root 2 here first to get R1 minus R2 is equal to 3 root 2 MA. So where's my R1 and R2s? I've got my R1 up the top. I've got my R1 here. I'll just get R1 first. R1 is equal to 2 mg over root 2 minus 2 ma over root 2. And we have R1 minus R2. So we'd have to take away, just do the sum here. That's R1. So if we get R2, I have R2 here. R2 is equal to MA over root 2. plus mg over root 2. So ma over root 2 and mg over root 2. ma over root 2 and mg over root 2. That's R1 minus R2. That's minus R2, and that's equal to 2ma over root 2. Okay, I'll just rub this guy out. You've seen this already. 2ma over root 2 equals 2ma over root 2. Okay, multiplying by root 2 and dividing by m is going to leave us with 2g minus 2a minus a minus g is equal to 2a. Is that right? So we're going to bring in 3a to the right. We're going to get g is equal to 2g minus g is equal to 2a plus 3a, 5a. A is equal to g over 5 meters per second squared. And just let me check. I had R1, R2 here was equal to 3 root 2 ma. So I just used the wrong part. I was looking at the end of this equation. So that should be replaced. That 2 ma over root 2 should be replaced by 3 root 2 ma. And if we were multiplying by root 2 and dividing by m, so that's going to become 3 by root 2 by root 2, which is equal to 3 by 2, 6a on the right hand side. So not 2a, that should be a 6a. So we 6a plus 3a is 9a. So a is equal to g over 9. So just be careful there. There's too much going on here in this video.